Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Nurul Shazana binti Abdul Halim. I am from Faculty of Science, University Malaysia, Kelantan. For this conference, I would like to present my study on the removal of methyl orange using CTA Aliquot 336 Electrospun Fibers from aqueous solution. Ladies and gentlemen, Textile Industries is one of the largest producers of wastewater. The presence of dyes in wastewater causes environmental pollution that can affect the balance of natural environment. Dye effluents are non-biodegradable, toxic, and difficult to be removed. Even small amount of dyes, which less than 1 ppm, are highly undesirable and visible. Methyl orange is an orange azoic dye. The discharge of methyl orange into the environment is critical due to color, toxicity, mutagenicity, and carcinogenicity of the dye. Previous research has shown that it is difficult to remove dye from the contaminated water using conventional wastewater treatment. This is due to the light stability and the resistant oxidizing agent to aerobic biooxidation. Therefore, initiative and effective treatment of textile effluents is crucial to protect the ecosystem. Advancement of membrane technology has been gaining trust as an approach to treat wastewater productively. The elevating market value in membrane advancement is primarily due to their characteristic itself, as well as the feasibility to practice sustainable approaches in industries. Electrospinning is a versatile method in producing electrospun fibers with fascinating features such as high porosity, larger surface to volume ratio, and also excellent functionalities. The binding of specific functional group to the electrospun fibers has proven them as a potential substances in adsorption of pollutants. Thus, this research aimed to investigate the extraction of methyl orange from aqueous solution using electrospun fibers made from cellulose triacetate, or known as CTA, as the base polymer and Aliquot 336 as an extractant. In this research, there are two objectives. The first one is to determine the best Aliquot 336 concentration, pH, and also initial dye concentration that affect the removal efficiency of methyl orange. Secondly is to characterize the functional group of CTA Aliquot 336 electrospun fibers at different Aliquot 336 concentrations using Fourier transform infrared spectroscopy (FTIR). Methodology of this study. In this study, there are four main methods. The first one is the preparation of CTA Aliquot solution. And then the second one is to prepare the electrospun fibers. The third one is the extraction of methyl orange. And lastly is the characterization of electrospun fibers. I will explain this further in the next slide. The first method is to prepare the CTA Aliquot solution. In this study, a various polymer solution at different Aliquot concentration from 5, 10, 15, 35 and 40 weight percentage was prepared. In order to prepare the polymer solution, both Aliquot and CTA was dissolved in a mixture solvent of dichloromethane and methanol with a ratio of 8:2 respectively. The total volume of solvent used was 10 ml. The solution was stirred continuously and vigorously until the solution became clear or homogeneous. Then, the solution was transferred into airtight bottle for further use. The second method is the preparation of CTA electrospun fibers. The electrospun fibers was prepared using electrospinning process. For this process, it consists the high voltage power supply, metal collector, and also a single syringe flow rate pump. To start the electrospinning process, the polymer solution was first placed in a plastic syringe attached with 23 gauge needle tip as shown in the figure. Then, the polymer solution was electrospun for 8 hours at 20 kV with a flow rate of 1 ml per hour and 140 mm of distance from needle tip to metal collector. After 8 hours of electrospinning, the CTA Aliquot electrospun fibers were collected and kept under dry condition for further extraction experiment. All CTA Aliquot electrospun fibers were prepared using the same electrospinning conditions with different concentration of Aliquot. The third part is the extraction of methyl orange. For this part, we studied 3 different parameters, which are the effect of Aliquot concentration, the effect of pH, and the effect of initial concentration. First, we start with the effect of Aliquot concentration. The electrospun fibers containing different Aliquot concentration were weighted about 0.1 gram. These fibers were put into the extraction solution, which contained 10 ppm of methyl orange at pH 7. At predetermined time intervals like after 20 minutes, 40 minutes, 2 hours, and up to 24 hours, the samples were taken from the extraction solution to be analyzed using UVV spectrophotometer at 464 nanometer wavelength. The concentration at different time interval can be determined by using equation from calibration curve obtained. Then the removal efficiency was calculated using this equation, where R is equal to initial concentration minus final concentration. These are divided with the initial concentration and times 100%. Electrospun fibers with the optimized Aliquot content then were further used to study the pH and initial dye concentration. In pH study, various pH of aqueous solution was used like 2, 4, 6 and 10 of pH. Step 1 to step 3 was repeated to determine the best pH for methyl orange removal. Then the best pH was further used to study the effect of initial dye concentrations. Step 1 and 3 was repeated again to study the different initial concentration of methyl orange using electrospun fibers with optimized Aliquot concentration and optimized pH. The initial concentration studied are in the range of 10 to 50 ppm. Lastly, the electrospun fibers were characterized using Fourier transform infrared spectra in the range of 500 to 4000. The FTIR was used to study the existence of functional group in CTA Aliquot electrospun fibers. Thus, different peaks were shown in the analysis. Results and discussion. Generally, the extraction of methyl orange by Aliquot is based on an ion exchange mechanism. The complex or ion pair formed between the ion and the extractant was solubilized in the membrane and facilitates ion transport across the membrane. In aqueous solution, methyl orange becomes negatively charged after losing one positively charged atom. Aliquot will then react as an ion exchanger, forming a neutral ion pair with the methyl orange anion from the aqueous solution as described below. This figure shows the removal of methyl orange using CTA Aliquot Electrospun fibers at different Aliquot composition. Based on Le Chatelier's principle, the increasing of extractant concentration will increase the reaction rate by increasing the rate of collisions. The extraction capacity of membrane should be improved when higher aliquot content is used. However, as aliquot concentration increase up to 15%, the percentage of extraction decrease. This is because as the extractant concentration increase, the viscosity in the electrospun fibers also increase, which cause the limitation in the diffusion of the dye and the extractant complex into the membrane phase. Another possibility could be due to the saturation of extractant in the membrane that resulted a decrease in extraction capability by changing the structure of the membrane surface. In another research where the range of extractant concentration used was between 0 to 20%, the optimum aliquot was found to occur at 10%, which showed maximum reaction where a further increase of the extractant will reduce the flux of the analyte passing through the membrane. In this study, the CTA electrospun fibers containing 10% aliquot shows the highest percent of extraction, which is 99.5% after 5 hours. Thus, this electrospun fibers was considered as optimal and selected for further experiment. The pH of the aqueous solution has a great impact in the adsorption process, affecting many parameters. In the aqueous solution, the methyl orange is first dissolved and the sulfonate group of the acid dye are dissociated and converted to anionic dye ions. Previous research showed that the performance of anionic dye extraction is directly connected with solution pH, as they reported maximum removal efficiency at lowest pH, which was favorable for the condition. In this study, the pH of the aqueous solution was varied from pH 2, 4, 6, 7, and 10. An optimized CTA aliquot electrospun fibers with 10% aliquot was used, and the initial methyl orange concentration was remained at 10 ppm. Based on the results, the extraction of methyl orange is more favorable at a lower pH than at higher pH. After 2 hours, the extraction of methyl orange reached more than 90% for all pH studied, except for pH 10, which is only 58%. This is probably because at lower pH, the presence of hydrogen ion is relatively high. This increment will favor the aliquot, which also has a positively charged functional group, to attract negatively charged methyl orange. In other words, alkaline solution showed the lower extraction of methyl orange is due to the presence of excess hydroxide ions, racing with dye and ions for the adsorption sites. It can be concluded that the extraction of methyl orange dye onto the electrospun fibers was influenced by the pH of the solution, where the acidic pH was more favorable. Thus, pH 2 was chosen for further study. In order to study the capacity of CTA aliquot electrospun fibers at 10% aliquot in extracting methyl orange, the initial dye concentration was varied between 10 to 50 ppm, and the aqueous solution was set at pH 2. Based on this figure, the extraction of methyl orange was the fastest at the lowest dye concentration, with 98% of removal in 2 hours. However, after 5 hours, the extraction of methyl orange for all concentration reached more than 97%. No further increment was observed for 10 ppm as the fibers already saturated with dye. This result suggests that the CTA aliquot electrospun fibers are capable to remove higher methyl orange concentration by increasing the contact time, and this trend is similar as reported by other researchers. As for FTIR Characterization Study, all CTA Aliquot Electrospun fibers show similar trend of peaks. The absorption band observed between 2,800 to 3,000 became gradually broader as aliquot content increased in the electrospun fibers. With reference to the pure aliquot, the strong absorption bands at 2923 and 2851 are assigned to the quaternary ammonium groups, which is in the accordance with the chemical structure of aliquot. Meanwhile, the peak at 1738 is assigned to the stretching vibration of the C double bond O group, and the presence of the bands at 1218 and 1035 are correspond to the stretching vibration of the C bond O. These absorption bands are corresponding to the aliphatic acetate ester of cellulose. In a conclusion, the CTA Aliquot electrospun fibers were successfully fabricated. Results reported here indicate that extraction performance of methyl orange on CTA Aliquot electrospun fibers was affected by extractant content, pH of aqueous solution, and initial dye concentration. The optimal methyl orange extraction achieved was 98% at 10% of aliquot concentration in pH 2 solution and 10 ppm of initial dye concentration. Thus, CTA aliquot electrospun fibers prepared using electrospinning process has potential to be used as a filter to extract dye from synthetic wastewater. That's all for my presentation. Thanks for watching. If you have any questions, please do not hesitate to contact me at Shazana, syazana@umk.edu.my. Have a nice day.